My name is Drew. I'm here to talk to you about browser and multi-threading in the browser. So this is mostly a practical implementation for trying to use the web browser for, most if not all of the things going forward. So, like I said, my name is Drew. Who am I? So lead, senior, whatever you want to call me, software engineer. So I've been doing front-end engineering for about coming up on 13 years now. So I pretty much come up with the web browser and everything it represents. So I specialize in, pretty much everything that is on the opposite end of the API, all the way from the design layer down to, when we actually call and fetch endpoints. So mostly in design implementation, technical architecture, repository architecture, anything and everything that has to do with front-end projects. So I've been on big teams, small teams. I lived in Milwaukee for a while, lived in Shanghai for a little bit. I've done front-end development in, the United States and China, and, I've been all over the place, right? So I've kind of really pulled my expertise down. I wanted to learn Rust or Go or, whatever you guys code in these days. But I decided to sort of really centralize my knowledge on everything that has to do with browser nuance. So what works on different types of browsers, how it works, the different APIs, and then how it changes from day to day. So why the talk, right? I really think that the barrier to entry these days for web development is very, very low, and that's an awesome thing, right? So anyone and everyone can get started with something, whether it's React or Angular or Vue, very, very easily. You can deploy something pretty much instantaneously, Cloudflare, Render, AWS, so on and so forth. But the thing that I think I've started to notice is that these getting started with videos or everything, it stops at a certain point, right? So that barrier to entry is finite. And then once you try to go on further than that and you try to scale it, that's when you start to encounter problems, right? So you can suss these things out usually by just seeing something on YouTube like getting started with X library here. So, I think that the content is great, but I believe that also the content is made more for clicks and driving ad dollars than actually good scalable stuff. So, with that, I think it's really important to talk about real world problems and real world examples rather than things that are contrived or things that have like a finite end. So doing these things allows us to talk about lesser known APIs, things that are hidden that you don't necessarily work with because the first 10 search results in Google or the thing that ChatGPT says that you should do is, really readily accessible. We'll talk about some trade-offs, scalability concerns, so on and so forth. So ultimately it all comes down to context, right? What is the thing that you're doing? What is the context you're trying to deploy it in? And how is it going to be used? And what are the other things that surround it? So today's word of the day, nuance, right? Who's tried to implement things in Chrome before? Now, who's tried to do that exact same thing in Safari? Exactly, nuance. So browsers implement things different ways. They have there's obviously the web consortium that looks at how standards should be implemented, and then whatever browser organizing group gets together and they really decide how they want to implement that spec. So you get a lot of nuance. So here's what we're going to talk about today. So we'll talk about browser fundamentals because I think it's important to kind of get back to basics and see what actually is the browser, how does it work. We'll talk about web workers and then why we should even create a web browser or a web scanner, right? So it's kind of a practical implementation for using web workers, but it's also, I think, a practical implementation too for talking about some of the other contextual things that go with deploying a web application. And then I'll go through a demo, so I'm going to walk through a live demo too. All right, so let's take a look underneath the hood of the web browser, right? So, what are processes, what are threads? And before I get started, there's a lot smarter people out there than me who work for Chrome, and they wrote this awesome blog. It's a 3-part blog. This is inside your modern web browser. So all the images I'm going to use here are all shamelessly stolen from that resource, but I'll try to go over a couple things that I thought were actually pretty prevalent. So your overall browser is broken out into a couple different processes, 4 processes namely. So the first one is your browser process. So that's anything that's in the Chrome application. So like your navigation bar, your back buttons, your forward buttons, so on and so forth. So that handles all the invisible things that it's outlined here. So anything that is kind of associated with navigating or loading or anything that talks to more of your OS layer, that's handled by the browser process. The plugin process, don't even worry about it. Flash, whatever. The GPU process is important, obviously the graphics processing unit. So that handles different tasks that the browser uses in tabs to delegate down to that specific tab. It handles requests from multiple apps, and it draws them on the same surface. So that's a pretty important process. But the one we're really going to focus on today is the render process, right? So that is anything encapsulated underneath your URL bar and in the space of the viewport. So that's typically what you work with. So the render process is composed of a couple of threads. Who's heard of the main thread, UI thread? Yes, okay. That's everything that you use in modern web frameworks these days. So or libraries, React, Angular, it's all working on the render process or the main thread. Now, there's also a couple of other threads the browser spins up that aren't necessarily associated with like browser processing. There's a compositor thread and there's also a raster thread. And these are associated with painting parts of the application. So in between all of those sort of like main fundamental things, the main thing that we're typically worried about is the main thread, and then what I'm going to talk about are any infinite amount of worker threads that you can spin up for the browser. All right, I'm going to kind of like just gloss over this real quick. So when you go to load a web page, there's a couple fundamental things that happen. So you have to take the HTML that you create and it parses it into a DOM, so the document object model. It pauses any sort of that creation to execute scripts. It interprets the CSS on each node in accordance with the specification. Then it calculates the geometrical layout, and then it paints and rasterizes that stuff. And that's for every single DOM node. So spans, divs, articles, sections, all of that stuff alike. So that's effectively known as DOM style layout paint. Sometimes you'll see it as DOM plus style layout and paint. So this is again, another shameless thieving from that amazing article that was written. But the overall kind of concept of this is that it's expensive to create, right? So if you change something on the style layer, that style, or the browser needs to implement what that style change was. It needs to recreate that layout, it needs to draw it, it needs to compute it, and then it needs to paint it. So all of this is very expensive, and that really kind of makes our job as front-end developers a little bit harder because there are a lot of things happening in the background. So a div is a div and you want to add some style to it. There's a lot more things that happen. So we need to make sure that we consider that a little bit more. So how does this actually translate to experiencing any sort of pause in the main thread? Well, JavaScript is executed synchronously. So anytime the DOM sees a new script or anytime the DOM perceives a change to it, it's going to experience sort of that page jank where you're loading different frames, and this is in the specific context of an animation where an animation is going over and over and over again. It's ticking, and then it's repainting, repainting, repainting. And then it sees, hey, there's a big chunk of JavaScript here. I need to do a big, expensive calculation, and then it stops. And you're like, well, what the hell happened? Well, that's your really bloated library stopping everything that you're doing and preventing you from doing the thing that you actually wanted to do, which is give the user a good experience. So, fundamentally, that's kind of what we experience. All right, so let's talk about web workers. So web workers were that underlying thread between the main thread and the compositor thread and the rasterizing thread that can help us really offload some of that, some of those heavy computations to be able to use the main thread for what it was actually supposed to be used, which is just rendering stuff. So like I said, there's your worker threads, and simply put, a worker thread is you can do anything you want with it in JavaScript, right? You can run it in a background worker separate from the main thread, but there's two kind of like fundamental things that you can't do with it. You cannot manipulate the DOM, and you can't reference the window. So you can't reference the overall like global window. And there's a few different types of workers. There's dedicated workers, which are responsible for having just one sort of responsibility. I don't want to say microservice, but it's kind of similar, I guess, but you want to make sure it just does one thing and does one thing really well. There's shared workers, which are a little bit different and they're a little bit more complex, where different tabs of your browser can go in and they can use the same worker, but the implementation of the worker needs a specific port that you access it through. So it's probably adopted in like 70% of browsers, I guess, right now. I honestly don't know. Go check the MDN docs. And then there's the service worker, sort of this like nebulous concept of what the service worker does, right? So a service worker is typically associated with a progressive web app that handles caching, that handles, it's basically this thing that sits in between your browser and your network. And you can handle different things back and forth properly by sort of standing in the middle of what you're requesting from the network and then what you're actually using and rendering on the browser. But we're talking about dedicated workers right now. All right, so data transfer. When you send something to a web worker, you pretty much structure clone it. And the main kind of concept behind this is like the browser's implementation of serialization. So everyone knows what serializing is here? Yes? Okay, cool. We're on the same page. The browser obviously, nuance, does it a little bit differently. So when you send something from the main thread over to a worker, you copy it. And that is, it's computationally expensive, but the algorithms are fast enough where it actually doesn't really matter too much. The difference concept is a transferable object. So a transferable object is this sort of like, I don't know, this different thing that the browser implements, that you can take different types of data or different types of APIs, and you can transfer those underlying things like a buffer, like image data, and you can take the responsibility of ownership in memory and transfer it over to a web worker. Again, a lot of minutia, but it's something that I think is pretty important to cover. All right, so why would we want to do something like this, right? We all went through COVID. Who's used the native barcode scanners to scan menus, right? Everyone? Yes. Okay, cool. So why we want to go about doing this, right? Why do we want to put that stuff into the web? Like for me, the native browser works just fine. So there's lots of reasons for it. And I think some of them come down to a lot of the topics that we've been talking about recently, I guess in all of these talks as well. So I'm talking about walled interactions, right? When you use something in the browser or in a web application, you are using it in the context of what you want to use it for. So when you use your scanner, you're basically going to be using that, and then you're going to be kicked out of whatever that native process is over to a browser. It's typically a link. So having these walled interactions broken down by using the thing that you want to use in the context of what you're actually using it for is super important for time. It's super important for processing. You can parse sensitive data. You don't have to re-authenticate or go through another authorization server and do code grant exchanges, so on and so forth. So you're doing things in the context of what you're actually wanting to use them for. Offline capabilities, I think, are a kind of no-brainer. I mean, what I'm going to show you today is all offline, so you don't really need a lot of networking power to do stuff like this. I think accessibility also is another important part too, because these web APIs are getting so intense now that you can do a lot of the things that you normally would do with a native application. So one thing I actually discovered, I was like, I wonder if we can do haptic feedback, right? So there is a web API for that. So it's called the navigator.vibrate web API. Honestly had no idea it existed before this talk. So, I'm still learning things, and the thing is like when you can take some of these sort of inherent web APIs that have been implemented in these browsers, you can really kind of tune these things for accessibility. You can play a sound, you can have haptic feedback. Let's say that you don't really understand where let's say a code is. You can have different hints based upon the image data that you're processing to say, move it left, move it right? So accessibility is this thing that, it was always kind of fundamentally known as front-end developers that we should definitely take care of, but in the same sense, it's becoming much more important these days because we are trying to deploy these applications and make them as accessible as possible to everyone who's using them. Convenience is another thing. You can pretty much use any device that you want that has a webcam. So I can use my phone, which I'll show you in a second. I can use my laptop. I'm not just relegated to using one specific device, like an Android or an iPhone or something like that. And then consistency. So I'm sure, I don't have an Android, but you can use an Android to scan a code, and you get one specific experience. You can use an iPhone to scan a code, and you can get a completely different experience. So ultimately, what we want to do is we want to try to drive consistency and make sure that we only have one specific interaction that manages all of the code scanning, and then we can base our brand off of that, or we can enhance it, and then we only have to enhance it once. We don't have to worry about sort of cross devices, only cross platform. So those are some real world reasons. So let's talk about actually how about going about doing this. So there is a barcode scanner API. So I almost killed my point here before I actually even got started. But oh no, my image didn't show up. Oh, maybe it did. Okay, cool. So I have a couple of requirements. We want to be able to run it on any device. We want to be able to run it in the web worker context, and we also want to make it as asynchronous as possible. But again, nuance. The problem is that it is still a experimental technology, and if we scroll down, anything that has red on it is bad. Duh. It's all partially implemented. It has some pretty concise APIs over here on the left, like detect and get supported formats. But I have an iPhone, and if I can't use it in Safari, we're SOL at this point. So that was the first kind of method to go about doing that. It's still experimental, not supported. And that's the problem with browsers these days, is that everything is nuanced. There's like partial support, there's kind of support, there's maybe support, there's full support. And honestly, you don't really even know if it's supported until you actually go and get your hands dirty. So there's another one. There's the Media Stream Track Processor API. And what that basically does is it sits in between every single frame of the video that you're rendering in your webcam. So let's say you start a stream. You can sit in between that, and you can process frame by frame as the video comes through. You can hijack that, you can write to it, and then you can serve it back to the user. But let's go check the compatibility again. Nice. Way to go, guys. So, I know I said in the beginning that libraries are bad, but what are we relegated to? We are relegated to a library polyfill. Yes, wonderful. All right, so from this perspective here, we've tried the different APIs that we really want to use. We also tried to use the browser the way that, the consortium wants us to use it, but, obviously, our car manufacturers didn't give us a wheel, but they said we needed to drive the car. So now we're at this point, right? We want to create this polyfill. So, but it also accomplishes all of our tasks here as well. So here's the overall pseudocode. So I'm going to start to dive into a demo. So what we basically want to do is we want to add a video node on the DOM. We want to detect for what type of camera that device has, right? So if someone's busting out their pink Razor from like '98 or whatever, that's obviously not going to have a great camera for support. So we use media detection APIs here. So we'll start that video track, we'll read the barcode, we'll decode the barcode, we'll display the overall highlighted region, and then profit. So here's kind of what we're going to be doing. So the main thread is green, and for every tick of the video, what we're going to be doing is taking the video, and we're going to be trying to translate it into something that we can work with. Obviously, some of the APIs for like really interpreting video aren't necessarily too mature, or they're partially implemented, so we can't use those. But what we're going to do is we're going to take the video, and every tick of the video, we're going to print it to a canvas. So a canvas element is something that you draw on. So if you do like Google Maps, or if you've worked with open layers before, any sort of mapping software, that's all done by like rasterized images in Canvas, right? So it's kind of this blank thing where you're like, hey, go from point X to point B down to point R, and you're just drawing and interacting with things very imperatively. So we're gonna write it on the Canvas node. We're gonna turn it into image data, because that's image data that we can work with, and then we're going to this awesome nebulous function, decode barcode, and then we'll display the result. Demo. Here we go. This is where it all comes off the rails. Okay, so ground rules. This was implemented, and I'll just give a couple contextual points. Can we see this on the phones okay? Is that too small? Want me to bump it up? Yeah. How's that? Bigger? A little better. That's excessive. All right. Okay, cool. So this was written in React. This is also written, or it's using Vite, which is, if you saw Ken's meta frameworks, it's just basically a build system to take all my JavaScript, compile it down to stuff that the browser can understand. It's written in TypeScript, so if you don't understand the notation, I'll try to walk you through it a little bit. I'm also like this, I want this to be kind of interactive too, so if you guys have a question, just pop your hand up and I'll try to stop and review it. But let me jam for a second, and then we can talk. This is pretty indicative of what you're going to see in the wild, right? So you have a hook. A hook is basically, if you don't know it in React, it's a function that returns something else. It just uses some other conventions. So we have this thing called useScanner, and what this does is it's going to return this function that I can then use to initialize my video element. So I have a couple like debug parameters in here right now. I'm going to give the video a max width, and then I have a handler. I'm not going to go into the handler or anything like that, but this is basically to show you the demo. So there's two things around here. I have one video node, which I talked about before, and then I have this scanner animation. And the scanner animation is used, or it's created using framer motion. If you guys haven't seen it, you probably have seen it in the wild. But this is done intentionally, not for optimization, but to kind of illustrate how the browser will stop and it will start to skip a little bit. So I think the first thing I'm going to start to do is, who's lost? Anyone overly lost? No? Okay, we're all with me. Sweet. All right, so the first thing I'm going to walk through is like how we actually did this, right? How is this done? So I'm just going to assume that everyone knows what some of this notation is, but I kind of want to like dive into the concepts a little bit. So this canvas scan ref that I have right here, a reference in React is nothing more than like using document, get, whatever the idea is, right? So we're just getting a node. We're going to say, hey, I want to get X node. And this canvas scan ref node, that's the node that I basically wanted to use to print that image data out to it. So this thing's pretty important. I'll go into this masking ref in a second, but we can ostensibly ignore that for the minute. So this function is something what's called a callback ref, and when you attach it to a reference of a node in React, you basically can expect when that thing loads, like jQuery, what is it, dot wait or dot ready, that's kind of ostensibly the equivalent here of this node. So if we get a video node back, we know that this element has rendered on the page and that it's initialized for to be used. So like I said before, we're going to set the video stream. I'll dive into that real quick. That's just using the navigator. It's checking my media devices. It's going to use a specific facing mode to get my environment. I'm setting a ratio. I'm pumping the resolution up, and I'm using a frame rate of 30 seconds. So again, I'm not going to like dive into that too much, but basically I'm getting the webcam that is environmentally facing. All right, from that point then, and I wrote kind of like this logger here to show you a little bit. I'm setting the video node to a max width, and then I'm just making sure it plays. And then from that point, there's two event listeners that we're going to use. The first one is load metadata, and that is essentially when the video gets everything that it needs to understand what's going on. It's overall intrinsic height, then intrinsic height, intrinsic width, resolution, density, all that kind of stuff. We're going to set a couple of attributes here. So we're going to set that image data node that I talked about to the video height and the video width. I'll go into masking in a second. And that's pretty much it. So I'll share this debugging method in a second. But this is kind of all that's really involved with like setting the image to, or using the metadata outside of the video to set it to a video height and video width. The next thing that we do in order to convert it to image data is that we need to get the context. So I got this node, and now I need to get the context of it, and that allows me to convert that to image data. So I got a couple short circuits here, just returning or throwing errors. And then from that point, here's where the magic sauce happens. So we have this time update function. So every time that frame or every time that new video tick happens, that's pretty much what we really want to focus on here. So what we're going to do is we're going to take that scan context and draw it on, or we're going to get the video node, which is whatever the frame was, and we're going to draw it to our canvas. Here's that image data I talked about. We're just going to get image data. And then from this point, we're going to scan our barcode. I'm not going to go into the overall, I mean, if I have time, I'll go into like how it's scanned, but this is ostensibly it. You get a canvas, you write some stuff to it, you get its context, you get the image data, you pass an image data to a parser, and then that's pretty much it. So let me go to the demo. All right, cool. So everything right now is happening on the main thread, and I have my scanner here. You guys see that? All right, cool. So up on the top left is what we're scanning. So that's the video. The pulsating boxes, I don't know why I'm pointing up there, I can look at it right here. So the pulsating boxes are that animation, and then what we're processing is that canvas node that I was talking about. So that's the actual image data that's being sent to whatever function that we're using to decode the image. And then on the right is our output, right? So that's just the quick logger that you're seeing. So you can see pretty quickly that, we're going maybe like three or four logs a second, I guess. Maybe 4. I don't know. I'm not like an expert in frame rate or anything like that. But essentially what we're doing is this is all that we're processing here in the bottom left-hand corner. So let's go ahead and scan something. So Underpants, Thunderpants. It's our first example. This book is great. Okay, so we'll just hover over it. I have to figure out what screen I'm going to watch. All right, there we go. So up in the top hand right, you can see the result. And on the bottom right we can see our CPU usage, right? So we're at probably like 17, 23, 19. So we're on the main thread right now, and that seems okay, right? I think it's okay. You guys think it's all right? Yeah? All right, cool. I think it's an acceptable number. So when I did this demo and I like did the whole thing, I was like, oh my God, like this is completely like disproving my point here. So then I thought about it a little bit more, and I said, all right, well, what's a good use case for this in order not to have a contrived example? So we're at 25% right now. I got kind of stuck. So if I go back to my slides here real quick, I did really what any good developer would do in 2023. I booted up ChatGPT. So again, in the interest of making sure that I wasn't providing a contrived example, I wanted to understand a little bit more about what's a good use case here. Like why would I continue to need to put this stuff in a web worker if it's like performing at 30%? And the good old robots answered, it had two good reasons. So first one is depending upon the light and depending upon the resolution of the image that you're scanning, you might want to add some sort of extra layer of image processing. Or another one that was completely way over my head is that you can do like digital watermarking with it, which will require more image processing, right? So that's when it gets down to the problem of like, okay, it's performing acceptable right now on my souped up laptop that has, 4 whatever, I don't know, I have to tell you how many cores it has, like 1,000, I don't know. That my wonderful company provided me. So it's performing at 24, 25%, but let's get it down to a lower device. Let's get it down to like a Pixel 4, right? Or let's get it down to even an older device. So in the interest of trying to make sure that every single one of our users has all this kind of stuff, we want to make sure that we're optimizing it the best. Like it's okay to leave it here, and that's kind of where things stop on the internet, right? That's where things stop in your getting started. Where in the hell do we go from here? So from that perspective, we can do a little bit more. So let's take that example of doing some more image processing. Let me go back to my slideshow. You can tell I really present a lot. All right, so let's do that. So I actually just had to figure out how to pronounce this because I've been pronouncing it wrong for the past like 10 years. So this is the Gaussian blur. So in image processing, a Gaussian blur is a result of blurring an image by the Gaussian function. So I think you can kind of get it, but what it basically does is it gets a specific point of your image, and then it gets the context of every pixel around it, and then it continues to blur out, and you get this kind of, this glass thing, right? I took that right from Wikipedia. All right, so here's what we're gonna do. If we remember our main thread example, every tick of the video we're writing to our canvas state. We're getting the image data, but instead of doing that in the main worker now, we're gonna separate out into two. We're going to use the decode barcode. We're going to put that in a web worker, and then we're going to put our image processor in another worker. But first, in order to illustrate just how bad this could seize up if we tried to put our image processor on the main thread, I'm going to comment out process barcode, again, another nebulous function. And this is all readily available. And I think I just got kicked out of my iPhone here, so I'll use my other device. Yeah, that's me. Me looking at you, looking at me. All right, so now we put the image processor on, and let's take underpants, thunderpants again. Not too bad. We're at 22%. Let's take QR code. All right, if you can see it, hold on, I don't even think it reloaded properly. Let's try this again. All right. So what are we spiking at now? Yeah. I knew you guys had voices. All right, so look at the boundaries. And do you see that main thread jank that we're talking about? That's a problem, right? So we want to add one more layer of image processing. Let's say that we deployed this production, we were cool and happy with it. We got to a point now where we have to kind of re-architect exactly what the implementation is. We have to put web workers in. So I understand that like 30% originally is okay, and that's completely acceptable, but scalability is a problem. Like taking this a little bit further and using the proper methodologies of going about and offloading this really computationally expensive stuff, it's worth it. It's absolutely worth it. So let's go ahead and do that. I've never had VS Code this zoomed in before. I'm so disoriented. All right, so in the interest of time and my ability to demo, I have another branch. Yeah. All right, let's start at the top again. Okay, so I will admit all of this information I'm using right now is all readily available on the webosphere. ChatGPT kind of has a derivation of it. So this is all readily accessible stuff. It's all open source, and I have made this open source too. So there's a whole GitHub repo that you can use to evaluate both of these different types of scenarios. All right, so what are we going to do now? We're going to go and take our methods that we talked, or our functions, and we're going to put it into a worker. Let's see if I can get it. I can't get away with that. It's not going to work. All right, let's do the scanner. So this is the overall, if you remember that scan barcode function that I had before, this is the scan barcode function in a worker. There's two things for it. There's an on message and then there's a post message. And I personally think this API is pretty simple. There's a couple libraries out there, or there's one notably, it's called Comlink, and I think it's by Google. And it takes the abstraction, or it basically abstracts the communication back and forth from a web worker to a main thread. But I really think this is pretty expressive, and I think it's really not that hard to understand. So basically what we're doing is we're sending our data, which is our parameters, our type parameters, over to the web worker, and then we're calling that same function again. And what that's going to do is spin up another thread, and it's going to process that or it's going to scan that barcode, and then on the same side of that, we're going to have another one, again, very expressive. We're going to say, all right, send our data over the wire, we'll serialize it properly. We're going to process that data, and then we're going to post back done. Real simple, right? So let's go ahead and do that. Actually, let's just walk through the implementation first. You instantiate the worker by just importing it, new worker. I hope this isn't like too heady, but I mean it's as pretty simple as that. So when we instantiate the worker, we'll just look at the scanner worker for a moment. We'll use a React convention. This is basically just saying, do this when this renders first. That's it. It's not doing anything else. So we'll add an event listener. So we're going to listen on message, and then we're going to take the result from it, and then we're going to run our callback, which basically just prints it up into the top right of the demo that we had. And then this one, all we're going to do is log a message of done decoding. So let's go ahead and fire this puppy up. Okay. Right out of the gate, you can see the logger, right? So we're now down to about 12, 13% CPU usage, which I think is taking anything down 10% is probably a great thing to do, almost 15%. The one thing that I will admit right now is that this is using a virtualized list, so these logs are actually taking up a significant amount of CPU usage. So we'll just kill the logs in general. So what we're looking at now is 9%, and we're both processing an image and scanning an image at the exact same time. So let's go ahead, let's do the QR code, because that was the best one. So what are we at? 10, right? Let's turn the logger back on. Let's tail those logs. Look how fast that is working, right? So all this is happening asynchronously. All of this is happening off of the main thread. And we're now down to roughly what you would get just by running a regular web app. No, I'm just kidding. That's not the end. All right. So, and we'll do underpants to underpants too, if we can. There we go. So what are we really accomplished at this point, right? So we've been able to use a library because we evaluated that the things that are out there right now are partially supported. We've been able to take all of the load that was basically happening per frame per second, and we've reduced it down to something that is not only like super workable, but is super scalable. And then we can take that same experience and we can adapt it to any way that we want, right? We have one kind of central brain that is managing everything in the video sphere here. And then from that point, we're able to scale it and integrate it into our web app, right? So I think one thing to note too, if you were to take this concept and put it inside of your web app, it's not gonna stop at just like, okay, I have this scanned barcode. You're probably gonna wanna call an API. You're probably gonna wanna validate data. You're probably gonna wanna validate a couple of different things. Maybe you wanna validate the scan of it. Maybe that's not something that, or maybe you wanna like even further enhance the watermark. Who knows? You can do whatever you want with it, right? But ultimately what you're gonna be doing is you're gonna be freeing up the main thread to continue work that your user is going to be doing. You're going to continue to improve your user experience, and you really have something that's probably going to be deployed once, and you're not going to touch it again for a while unless you're actually updating the experience of the scanner. Okay. I'm not entirely, oh, okay. I will talk, how much time do I have? How am I doing? 12:05. I have, how much? 25? What do you guys want to talk about? Anybody have any like interest like behind the hood on anything? All right, I'll look at what I think is interesting. Here is your JavaScript animation.
What if you ran this on Safari? Just out of curiosity.
Oh, Matt. Let's do it. Why not? Of course, it's not private. I have to run this on SSL. Any WebRTC stuff like videos or audio has to run via SSL. And Matt proved me that I did not do my cross-browser testing. Boom. That's what happens. All right, let's get cool.
Sorry.
No, it's fine. But like I said before, nuance, right? I did this once. I did it. Maybe it took me about 5-6 hours to do. But the idea is that I wanted to try to prove a point in the sense that we got it this far, and then you iterate on top of it, right? Anything that goes with any cross browser, I think Safari honestly is the new IE. You can catch me on wax with that. Like it is incredibly painful to work with sometimes. But in that sense, it's really important that you try to evaluate all of the different possible scenarios that you could use, and then you just test them, right? And this is our, I guess if anyone was in Jess's presentation, this is our reload feedback loop that we can really implement pretty well. So the one thing that I kind of wanted to take a look at right here is the scanner, or I guess this canvas element here. So I talked about a masking node. And in order to beef this thing up, because when I got to the point of like 30% CPU utilization, I was like, oh my God, what am I gonna do? So I tried to beef it up a little bit more. So what I'm basically doing here is I'm calculating the boundaries of whatever the image is on the barcode. So if I see it'll detect it, and then it'll write it in red. So that canvas node is happening automatically. So again, this is all stuff that can be done off of the main thread. So if I go back to, let's see here. If I go back to my code right here, I said I talked about this canvas node, or this masking node. This is what I'm creating up here. So I have this canvas reference that I'm creating in memory. So I'm just creating an element right here. I'm not adding it to the DOM yet. I'll do that in a second. But basically when the video says, hey, I'm ready to rock. Like I have a video stream, I loaded my data, like this is the resolution. I can then take that canvas node, or that masking node, and I can add some stuff to it. So I'll set its height and width equal to the videos. I'll set it absolutely to it. I'll set the top and the left positions of it on, basically I'm just overlaying on top. I'm gonna add a class of scanner to it, and then I'm gonna find the parent element of the video node, which is that scanner, I guess that div, and then I'm gonna append a child to it. So I'm going up the render down. Welcome to the DOM. So that's all that's happening, and then when I go to actually write that, I'm just taking the image data from the scan, and then I'm going and taking that masking node, and sending it over to a web worker. So there's a lot of APIs here I'm probably not going to get into because I don't want to get like too deep into this. But essentially, a canvas is another transferable object. So like I said, it's like the browser has its own different way it wants to serialize stuff. This is a special object that you can send over the wire, and you can transfer the memory from the main thread over to the next thread. So you have all these levers that you can utilize, and they're adding more and more each week. I don't even know when this stuff comes out. I really haven't found a good resource or a good cadence to figure out like when new web APIs are happening. But this is basically all you really need to do. You just need to take stuff that you're doing on the main thread and transfer it over to the worker thread. I guess that's kind of all I really had to cover. I can go. Let me see if I have any more slides. Thanks, guys. That's it.